Okay, so I think we're on now. So give a round of applause for Phil, all the way from the States.
All right. Well, that was the first 5 minutes, getting image on the screen. So hopefully things will look up from there. So you've gotten two actually really nicely done kind of end user, what I would call end user talks. We're going to shift gears way to the other end of the spectrum. Hopefully I can keep your interest. But the containers that people are running, we just keep saying the word Docker, but what does that actually mean? What's underneath that, and how has it changed in the last 4 or 5 years? And so that's what I'll take you through. What's been happening at that level of the actual Docker engine itself. Hopefully, I'm a reasonable person to do that because ignoring the title and all those other things, I've been a maintainer in the Docker engine since about 2014. Late 2014. So I've been contributing to Docker upstream, and then that became the Moby project, and then Containerd. We'll talk about where that came from and what that is. I'm a maintainer there as well, and part of the foundations and projects that are over this part of the ecosystem, like the Open Container Initiative. We'll talk about what that is. I'm on the technical oversight board for that. So I spent a lot of my time focused upstream in open source around containers. I do that on behalf of IBM. So I work for IBM Cloud, and we're that cloud that when people list Amazon, Microsoft, Azure, Google, sometimes they'll say IBM Cloud, but we'd like to be in that list someday. So that's what we're all working toward at IBM.
You're coming after Oracle.
Yeah. Oh yeah, and Oracle. So you've heard a lot about containers. I found this amazing phone booth over by the river yesterday. So no, we're not going to talk about C containers, but as a really bad dad joke, we will talk about OCI containers and what that means. So yeah, the Docker engine. All evening, people have been talking about building Docker containers, running Docker containers. Who here can claim they used containers before Docker existed? Anybody? It was possible, right? I see a few hands. So Docker did not invent the concept of containers. Linux had a set of technologies that existed, mostly in the Linux kernel. There were other projects, LXC. Maybe some of you heard of that or used it. There were cool kernel developers, hand creating namespaces and running things in containers long before that. But 2013, about 2013, maybe some of you were playing around with containers then. Into 2014, I would say is the huge curve where all of a sudden everyone's talking about Docker and containers. And really the core of that was something we call the Docker engine. That was the open source project that the company at the time that became Docker Inc. Released and gained huge popularity. For those of you that did play around with containers with LXC or other ways that you could use those Linux features, I would say the two of the main reasons that I think Docker sort of took the world by storm is they really consolidated all those capabilities that you could get from LXC or you could get from knowing about those kernel features and writing scripts to kind of mash together a network namespace and a PID namespace. They put all that in this one binary that you could put on a Linux system, and all of a sudden you had a client to run containers that had a daemon that could manage these container processes, had a build tool with this nice Dockerfile concept where you could say how you wanted to assemble a container image. And then I think the second piece of that, so the consolidation and simplification of all these complicated features into this single tool, the second piece of that was to create Docker Hub and the Docker registry where you could actually share the output of this container image. You can now share it and use it, either share it with the world or use it within your company or stand up your own private registry. And so, for those that use Docker in that era, all of a sudden you became very comfortable with these commands: Docker build, Docker run, Docker PS, Docker push and pull. And so, the first couple of years, again, that's about the time I got active in the open source project. Everyone was falling in love with this use model and trying to add all kinds of new capabilities, new features, support for different platforms. And that's where IBM got involved. We wanted to bring it to our power systems and our Z mainframe systems running Linux, but on these other architectures. Raspberry Pi enthusiasts got involved and made ports for ARM, which today even Docker still supports ARM and ARM64. So there's a lot of activity in these years, but really at this point, Docker is a single binary on your system. Everything is packaged in there. There's a component called libcontainer, which is really what's talking to the Linux kernel and assembling the container features for you at the time. But all this is really being assembled into this one binary, which again is easy because now there's a single file I can copy around to my servers, and magically I have Docker. But it was also at this time that not only was LXC around already, but you had other ideas about how to assemble these same capabilities into different tools. And so CoreOS created Rocket, which was an alternative to Docker, some different ideas about how to assemble images, how to run containers. And, for those of us sort of more intimately involved in that era, you can think of it sort of as the container wars era of trying to make sure that there wasn't a huge splintering of the community in different directions. And so we're going to walk through this in more detail over the next 10 or 15 minutes. But essentially, we went from the single sort of statically linked binary to a set of different binaries and even different open source projects that now comprise, you can use that same UI, those same commands, but today the daemon is separate from the client. The daemon is talking to something called Containerd. Again, I'll explain what that is in a minute, which actually drives runc, which is an even lower level. That libcontainer component I mentioned a few minutes ago, that was contributed to the Open Container Initiative and became its own binary. And so today there's a series of binaries that when Docker is packaged have to be available on your installation for Docker to actually operate. Docker then said, everybody wants their feature inside Docker. How about we make certain parts of this pluggable? And so as Docker has continued to grow, there are ways to have your own networking implementation or an external volume storage driver and so on. And so let's talk through how Docker went from the single static binary into these various components. So I mentioned sort of this container war era of different opinions, different ideas. Some people wanting Docker to move in different directions or to have different concepts about how some of these things are assembled. A lot of the major vendors who were also very active in the open source project. So we had people from Google involved in the Docker open source project. Microsoft was there, IBM, Red Hat, and many others. As people met to discuss sort of these differing opinions, the solution that everyone agreed to was to create this body called the Open Container Initiative and basically specify what we all could agree on would be what is a runtime of a container? What are those properties of how do I run a container? What's the command to run? Which namespaces to use? Which files to allow, device files to allow the container to have access to? And so that body was formed in the summer of 2016. And out of that came not just a specification, but the actual code for runc. That was the libcontainer part of Docker brought out and put into a separate binary. So again, a lot of I won't belabor reading this whole slide. Actually, I said 2016. It was summer 2015. And then over the next few years, many different companies worked together to reach the 1.0 specification, which seems like it wasn't that long ago, but now it's going to be 2 years this summer since the 1.0 version of the spec was reached. And there's two specs. So I mentioned the runtime, but also the image specification. So can we all agree on what a container image is? Maybe we have different implementations, but if we can all say what an OCI image is, then Docker can have their own tooling and others can develop their own tools as well. And so really thinking about it in the terms of like a Docker run command, OCI specified a JSON configuration that would match the kinds of things you might think would be in a Docker run command, like which volumes am I going to mount, which container base layer am I going to use, what command will I run, and all that gets encoded in this OCI configuration. Runc, again, is the implementation that actually knows how to read that spec and to look at a file system and to start your container for you. So you can almost think of today's Docker doesn't have the code that actually talks to Linux and sets up your container and starts that process. That's all in runc today. And so Docker, again, is a higher layer above that. Again, there's a lot of words here, but effectively, runc is that lowest layer that's actually talking to the operating system and the OS kernel to handle all the things about what we actually call a Linux container, why we even call it a container, all these isolation features. And so again, runc has had a ton of releases. It has over 200 contributors. It's managed by this Open Container Initiative body that sits underneath the Linux Foundation. And it's used by more than just Docker, and we'll look at some of the other uses of it as well. But not to get lost in too many details, let's step up one level and talk a little bit about Containerd. Again, the idea here was that as Kubernetes came on the scene, you just heard in the last talk, Docker had Swarm. All of a sudden, Kubernetes is gaining in popularity. And Kubernetes was using Docker as its runtime, but even the Kubernetes community said, Docker's moving so fast, they're adding all these Swarm features. We just want a boring container runtime that Kubernetes can use to execute containers. We don't need the rest of the Docker suite of capabilities. And so that's really the source of the discussions that led to the Containerd project. Again, it was really a continuation of the idea that runc was spun out from the Docker code base. Now you had a very simple binary that could execute containers. Containerd could sit on top of that and really do the management of runc processes. So more of the daemon concept that Kubernetes could now talk to the Containerd daemon and ask it to start and stop containers that would make up your pods. And then Docker would donate this to a foundation, which again was the CNCF, the Cloud Native Computing Foundation. So there could, all kinds of groups, not just Docker, but others could collaborate around Containerd as this nice sort of common, boring, in a sense, container runtime that anyone could use to build higher layer tools. So again, Containerd has been around for a good while now. It was initially within Docker and then contributed out. So the 1.0 branch is we made the December 2016 announcement to contribute this code to the CNCF. That's when the 1.0 branch was created. And it became more than the initial branch, which was really just managing runc, but the 1.0 version knew how to talk to registries, so you could push and pull images and more of the metadata and snapshot drivers like in Docker talking to the actual overlay file system. Those features were added Containerd. And then more recently, Windows support was added. Again, Microsoft is part of the Containerd community as well. I think in the interest of time, I won't spend a lot of time on the architecture of Containerd. Myself and others on the Containerd maintainer community have given lots of talks at KubeCon and other places. In fact, if you look at the deep dive from KubeCon Seattle, we've had someone with better drawing skills actually make a much nicer diagram of the architecture. So that's a great talk to watch on YouTube if you want to understand. It's got a very simple model that, again, really just sets up the basic needs for both Kubernetes to use Containerd as well as the Docker ecosystem to use Containerd. And again, all that sits on top of an OCI runtime such as runc. So what does Docker today look like when we say, hey, I've got Docker 18.09? What does that look like? It's actually a collection of quite a few open source projects today. So the actual Docker client has moved out into its own project, so Docker CLI on GitHub. The Moby project, which is the original Docker engine, continues to be developed in that project. I just mentioned Containerd, which is a CNCF project in its own GitHub repo. runc is under the Open Containers organization. All these get combined. You can actually go look at the Docker/Docker-CE repository. When Docker decides to make a Docker release, Docker engine release, they obviously will collect up all their dependencies, select versions that Docker release is going to be based on, and so you end up with a combination of various releases. Currently, I think 1809 is using the very latest Containerd release. And again, so you can actually see that if anyone uses Docker for Mac and you look at the settings page, it'll tell you here's all the components that we use to create this release. And so you can think of, I think I actually put it here, Docker today is an open source based product. It's not just an open source project. Docker, the company, is putting together a product made up of quite a few open source projects, which both include free community products like Docker Desktop. And that's now, for those that heard the news from DockerCon, just as Dom said, 6 weeks ago. Seems like forever ago, but I think it was just December last year. They now have a desktop enterprise. There is the Docker Enterprise product. There's the Community Edition engine. There's Docker for Mac, Docker for Windows. All these are built out of many, many different open source projects. Some I didn't even talk about, such as all these kits, HyperKit, VPN Kit, Linux Kit. All these are developed in the open, but yet are used to build what you would call or know of as Docker on your desktop or Docker on your Linux server today. And obviously Docker, as a company, hopes to make money off that and obviously sell enterprise products based on these projects today. So really, as you can see, Docker has grown from sort of this single open source project into a huge variance of projects, some managed by Docker and some managed by foundations. But what that's allowing is really other projects, other products to use these layers, not just to build Docker, but to build other things. And so if you look at runc, Red Hat has taken that and built an alternative runtime for Kubernetes called Creo. Some of you may have heard of that. They have an OpenShift, Red Hat's OpenShift Kubernetes service is moving to Creo as its runtime. There is a sort of cloud-based containers as a service project called Cycle.io. The founders of that startup actually use runc directly, so they don't use the Docker engine, they don't use Containerd. They've built their entire containers as a service offering out of runc, and there's a bunch of other OCI spec implementations such as lightweight virtualization, so Kata containers. If you've maybe heard of Intel Clear Containers or Hyper.sh, those projects have merged into a single project called Kata Containers. The high performance computing community, there's now a startup that's creating something called Singularity that implements the OCI. There's other, Google has gvisor, IBM Research has Nabla. Basically, by creating a spec, you can see now there's potentially many variants of types of runtimes that are maybe more focused on a certain use case. But because of the layering now, this makes it very easy to have alternative implementations of how a container runs, but still use the higher layer ecosystem, whether that's Kubernetes, Docker, Docker Swarm, etc. Containerd, we're currently on a path to graduate in the CNCF out of the current stage that we're in within the Cloud Native Computing Foundation. And so we have a proposal PR that lists all these projects that are using Containerd today. Again, Docker is still maybe the largest user of Containerd, but Rancher is using it in a project. Google's managed Kubernetes service is switching from Docker to Containerd. Our IBM Cloud managed Kubernetes just switched from Docker to Containerd. Alibaba Cloud in China has built a huge number of projects around Containerd. Again, they potentially could be one of our largest users, again, given the size and breadth of the cloud ecosystem in China. So again, the point here being the layering of splitting out these pieces has allowed people to innovate in other ways, not just to be used by Docker, but to be used by other projects as well. I just mentioned Kubernetes has been using Docker as the runtime underneath the, so when you run Kubernetes, there's the node daemon kubelet that needs to actually talk to a container runtime to execute the containers. For a long time, that was simply using this Docker shim to talk to the Docker engine, which again drove Containerd, which drove runc. And so part of the Containerd project has been to offer the same capabilities by talking directly to Containerd. And so when I just mentioned that Google Cloud and IBM Cloud are in the process of making this switch, that's just an operational efficiency. It doesn't mean Docker can't continue to be used in that model, but for an operator, it may make sense to have a simpler stack on the server side of that managed offering. So again, there's a lot more background. There's some talks all about this, but I just wanted to show that as an example. I think we're over time. I mean, what I normally show from a command line is simply I can start a container from Docker, and then in Containerd's client, I can see that container, and I can even use runc to see that process running on the system under runc, just showing that layered approach. If someone wants to see that, I'd be happy to show that at the end. Okay. And so again, I think the summary here is that given the ecosystem is now agreed, okay, yes, we can all speak OCI. We can talk about OCI runtimes and OCI images, and now the actual Docker distribution API. So when you talk to a registry, the push and pull operations, that also is coming into the OCI this year. And so once we all agree that these OCI protocols and specs are how we talk, then everyone can play and interoperate in that world. And so, you know, all the registries from the clouds, the private registries like Docker Trusted Registry and their enterprise product, Docker Hub, the open source project, all these speak Docker image format today, and the OCI image format is based on the Docker image format. But slowly, these projects are switching to speak natively the OCI image format. Again, with build tools now knowing how to speak in sort of pure OCI images. So whether you use Google Container Builders or Builda from Red Hat or Conoco or the BuildKit open source project from Docker, all these tools are going to be interoperable because they're all speaking the OCI image format, which means, again, all the runtimes, whether we're talking about enterprise products or the desktop products or the lightweight virtualizers like AWS Firecracker or Creo, you know, again, all these products and projects will be speaking in OCI. And so that means I can build a container and I can run it in Docker on my laptop. I can run it in Docker Swarm. I can run it in Kubernetes. Cloud Foundry has adopted OCI. Some serverless projects, OpenFAS, OpenWhisk, Knative, are all based around container images. And so, you know, not to say there haven't been bumps along the way, but I think we're in a really good place with the fact that, you know, it would be a really sad place to be here 5 years into the container craze and say, oh man, this container image only runs on Kubernetes. If you want it on Swarm, you have to use this other tool. And so, so really, I think the OCI and a lot of the standardization has led to a good place that I think we have a lot of interoperability and hopefully a lot of room for innovation for different projects to be able to continue down this path. So that's all I have. I think we're a little bit over time. I'm happy to take questions, or if people are ready to scoot out, I can just stick around. But